Bench testing the 1958 Buick non-fog light option headlight switch, serial number PJD06102026, offered by TT Parts Rebuilding. Run-up test. Test number 1, tail and parking light operation. Test number 2, tail and headlight operation. Test number 3, dash lights set low to high. Test number 4, circuit breaker test. Test number 5, switch terminals insulated from ground. Using a fully charged battery during the run-up test, we will be under boost. Right now we're reporting 12.75 volts. Now under boost we're at 13.56. In Fahrenheit degrees, we're going to monitor the rheostat temperature. Right now we're at ambient at 84-85 degrees. Test number 1, tail and parking light operation. First position, have our tail and parking light, and we're going to set the rheostat to low and off. Again, test number 1, tail and parking light operation. First position, tail and parking lights, and off. Test number 2, tail and headlight operation. First position, tail from parking. Second position, front parking lights come off and we have our headlights on. Back to first position, headlights off, parking lights come back on and off. Test number 3, dash lights set low to high. First position, have our tail and parking lights. I'm going to rotate the rheostat from the off position for the dash lights to low. This would be your dim setting. And the rheostat temperature now is at 91 degrees. Let's go to mid position on the dash lights, to bright, and full bright. Second position, headlight position, dash lights are set at full bright. Let's go to mid range, to dim, dash lights off, dim position, mid-range, back to first position, front parking lights come on, we're in mid-range on the dash lights, to bright, to full bright, back to mid-range, to dim, dash lights off. Right now we're at 95-96 degrees Fahrenheit. Go to mid-range, and off. Test number 4, circuit breaker test. Delco Remy headlight switches had a built-in circuit breaker. It's a bimetallic contact arm. Connects the battery to the headlight switch. And demonstrate what would happen in an overheating situation, we're going to put it in first position, simulate overheating of the contact arm. We see that the connection between the battery and the switch is broken. This protects the vehicle wiring and also the vehicle's headlight switch. Again, simulating expansion of the contact arm due to overheating. We see we have a disconnect between the battery and the headlight switch, protecting the vehicle wiring and the headlight switch. Features also available in second position, headlight position. Simulate expansion of the contact arm. You see we have a disconnect between the battery and the headlight switch, protecting vehicle wiring and the headlight switch. Back to first position and off. Test number 5, switch terminals insulated from ground. We're using a standard 12 volt test light. We see we have continuity back to the battery at the switch chassis. And demonstrate that switch terminals are insulated from ground. I'm going to probe each one of the terminals. Here at the chassis, we have continuity. This is our panel light terminal. There's no continuity back to the battery. This is our battery feed. No continuity back to the battery. Headlight feed. No continuity back to the battery. Taillight feed. No continuity back to the battery. And parking light feed. No continuity back to the battery. This is our circuit breaker. No continuity back to the battery. The only continuity we have back to the battery is here at the switch chassis. This demonstrates that the switch terminals are insulated from ground.